Thank you, Ken. So thanks for the introduction. My name is Mash Saker. I'm a computer science professor at Carnegie Mellon University, and I'm delighted to be here to tell you about our cloud computing course that we transformed from an in-class course to an online course that is being offered to students from Carnegie Mellon's global branch campuses. So we started with the class being in class, offered to tens of students at one campus, and we only used our own infrastructure for the projects. And what we've done is we've transformed it into an online course, and now we have hundreds of students from Carnegie Mellon's global campuses, and all of our projects are on Amazon Web Services. So as a quick overview, this course is not a distributed systems course, and it's not a cloud applications course. It's right in the middle. What we do is we teach students what are the systems concepts that you need to know, and what are the enabling technologies for the cloud, and what are the cloud services that you use so that you can build effective applications. About 90% of our students are master's students, 10% of them are undergraduate students, and they come primarily from Carnegie Mellon's Pittsburgh campus. We have a significant number at Carnegie Mellon's Silicon Valley campus, as well as Carnegie Mellon Adelaide campus, and we've had students from Rwanda, as well as the Qatar campuses. Interest in the course has been growing significantly. The first time we offered it as an online course was in the spring of 2013. We had 50 students. We moved up to 170 in the fall, and then over 200 in the next spring. And then now we are offering it to over 300 students from multiple campuses. So what is an online course from our perspective, and what model do we use to engage the students? So first and foremost, there's no lecture anymore. We do not meet in the same room. All the content, the activities, the quizzes that the students do, they do on Carnegie Mellon's Open Learning Initiative. And it's important to point out that the Open Learning Initiative is a Carnegie Mellon initiative that started in the early 2000s and is considered the golden standard in online education frameworks. It has not only the content development bit, but also all the analytics and dashboarding so that faculty can get the insight as to where students are struggling, reflect back on the learning experience, and see what can you improve for the next semester. And that's a wonderful resource. So we do all of our content, and our content is basically text, images, video, short videos, as well as activities. And these are activities that are very critical because you have to give students feedback on incorrect answers so that they can get unstuck on their own, so you have to think about them carefully. And then all the quizzes are done using the OLI framework. All the projects are on AWS. Everything the students do from A to Z is on AWS, and I'm going to talk in depth about that. If they have questions, they post them on Piazza, and since we have TAs that work extremely hard and are awake at different hours of the day and night, and at different campuses, they tend to respond rather quickly. Our average response time is around 20 minutes. We also have an in-class weekly recitation just in case things were not to go smoothly, and we videotape that recitation and video conference to the branch campuses and make it available to all students. So you're going to teach a class on cloud computing. Well, what do you teach? After a lot of thought, we decided that we do a big picture overview and then go bottom up. And with the overview, we say, well, what are the enabling technologies? What are the main concepts that enabled the cloud paradigm to emerge? What are service and deployment models, economic models, advantages, risks, what have you? And then we start at the bottom with the data center. And then we often get asked, why are you teaching students about data center design and what goes inside the data center? Well, just like we used to teach them about microprocessors so that they become more effective developers, Now we need to teach them they're programming the data center. So they need to know what could go wrong, how do you take advantage of bandwidth on a rack, and what are potential faults and where do they come from. So we discuss all of these things. We also discuss data center design considerations, power, cooling, PUE, and what have you. Then we talk about sharing resources on the cloud, and here we focus on CPU, memory, and I/O virtualization. And we talk about cloud storage. So we start from files and databases and dig all the way through distributed file systems, HDFS, PVFS, and NoSQL databases, HBase, DynamoDB, and what have you. And we finish with analytics engines for the cloud. So we focus on Hadoop MapReduce, but we also touch base on Pregel and GraphLab. This is a project-heavy course. So there are lots of projects, but Project Zero is a normalizer that's not graded. We just want to make sure that all the students have the background they need so that they can start the work well. And there we just ask them to provision resources, set up security groups, configure SSH, and do all of these things. And then we move into Project One, which is the shocker. We give students always raw data sets. So we give them Wikimedia data sets, which is page views of Wikipedia pages. And we ask them to come up with a sequential version of trending topics. And we give them 1 hour worth of data. And so they do their sequential code, and then we give them 1 month worth of data, which is a few hundred gigabytes. And then everything stops working. grep takes 4 hours. Copying the file is hard, moving files. And they start to recognize that now this is much, much different. And what they do is they have to write a parallel version, and we use EMR streaming because it's very easy to get started. They just have to write a small Python or what have you, mapper and reducer, and then they see when does parallelism start to pay off. And then we go into scaling and elasticity, and this is a very important topic in the cloud, and I'm going to dig a little bit deeper on the next slide in this project. And then we move into cloud storage, and here we again take them through the entire gamut of storage. We start with files, and we go all the way and have them build their own MySQL database that they replicate, and after they see that replication pays off for reads but not for writes, they then go ahead and shard the MySQL database, and then they compete with service databases such as RDS and DynamoDB. And then in Project 4, it's analytics engines for the cloud. So here we ask them to replicate the Google Suggest or Google Instant. And this is when you go to the search engine, you start typing, and it tells you what the next word is. So we give them a large data corpus, which is the Gutenberg English. It's in Old English, as well as Wikipedia English. And what they have to do is they have to write MapReduce jobs to count the number of words and come up with the probabilities that when you see a word, the highest probability is this is the next word with the highest probability. So then they build a language model, and they attach it to a web interface, and they mimic what Google does. And then Project 5 is actually a team project, and it's not sequential. So projects 0 through 4 are all individual. Project 5 is team-based. And unfortunately for the students, it runs in parallel to projects part of 2 and 3 and 4. There, what they do is this is a loosely defined project. We give them a large data set and a bunch of constraints, and we evaluate them based on their performance and whether they can do things within our budget constraints. And I'll talk in detail about that. But let's talk about elasticity and scaling. So here, I mean, no matter what web service students are going to build on the cloud, they have to learn about elasticity. They have to understand how do you scale up and how do you scale down and when do you do it to impact performance and budget and all of these things. So we want them to do these things, and we want to be able to grade them. So what we do is we give them closed virtual machines. 2 closed VMs. One is the load generator, and the other one is the data center instance that they're going to horizontally scale or vertically scale. And the load generator has a web page, so they can go and authenticate using their Carnegie Mellon Andrew ID. And once they've logged on, then they can trigger the load generation by the LG towards the data center instances. And now we are not involved at all. They're just doing this all on their own on the cloud. And the load generator is creating load, and they have to first manually scale up the number of data center instances so that they can meet a certain requests per second requirement that we have. And after they do that manually, they recognize that they're not load balanced, so they have to then instrument an ELB. And then from there, they do some vertical scaling, and then they do some auto-scaling groups configuration on AWS. And then to make it more interesting, we start to vary the load in very interesting dynamic ways to make it harder for them to achieve the RPS. So they have to be a lot more insightful and analyze the load they're going to see and come up with better mechanisms to scale. And they have to also account for failure. So sometimes your data center instance just dies. What are you going to do? How are you going to respond to that? And they should account for that. So we monitor. They have to monitor. They have to decide what metrics to monitor and how to trigger scaling. And we log all events that the students do on all the machines. We know a lot as to what's happening per student when they are doing their work on these VMs. And we monitor whether they achieve the RPS goal. And that's what we use to grade them, and also that's what we use to dissuade them from cheating, because they know we're monitoring many things. And I'll talk about cheating in detail. Okay, the team project is extremely interesting because it's loosely defined. It's 2 to 3 students per team. 1 terabyte of raw data from Twitter. We give them 6 queries that are very different, and they exercise different aspects of their web service, and these 4 constraints. They have to respond to each query correctly. They have to meet our throughput requirements. They have to do it within 2 budgets. There's a development budget that they have, as well as a per-hour budget for their web service. So they cannot go above $1.25 per hour once they build their web service that can respond to these queries, and they have to do it by our deadline. We've broken this project into 3 phases. So phase 1, we only released 2 queries, and what we've done is we've created a web service that helps them test their solution. So they submit the IP address of their solution, and then what we do is we test it by generating load against it, and then we tell them how well they are doing. So then they can iterate and improve on their solution. And if you see after phase 2, there's this live test. This is when they go neck and neck against all other student teams. For 6 hours, we hammer all student team submissions, and they see who's doing better than the other. That creates a very healthy competitive spirit, especially at a place like Carnegie Mellon, and such innovation in the solutions that we are seeing in the students. Things that my very talented TAs and I are always puzzled. How did they think about that? And it's just wonderful. We do the same in phase 3. We release all the queries, and then we run another live test. And that is due a week from yesterday. It's due next Thursday. I'm going to show you the scoreboard at the end if we have more time. Okay, so these are the 2 projects. Well, how do you design a project using the cloud? Well, first we say, what do we want the students to learn? What are our objectives, and what are the learning outcomes? And after we think about those carefully, for this particular project, we say, what can the AWS services do? So we think about those, come up with a project idea, and we see if it's achievable. We identify a data set that we're going to use, design the different project steps. We actually develop the project, and then we see what has to be done and whether the insight that we had set out to do is actually met. Do students really learn the things that we set out to do, or does it become a cookbook recipe? Enter here, get that, and we need to move away from that and make sure that there's exploration involved. Well, we're not done. Now we need to make sure, can we afford it? So students, you can give them a project, but if you don't scope it well, they might not do it in the period of time that you give them to do it, but also they might not be able to do it with the budget that you give them, or they might need a lot of money to be able to complete the task. So then we study the data set size, we estimate student effort, and then we start thinking about the number of resources and the types of resources that they can use, and we iterate there until we have it right. Once we have it right, then it is fully tested from the write-up, from the final write-up 3 times by 3 different TAs. And once we think we've ironed out all the bugs, we release V2 to the students. You never catch all bugs. There are always bugs. So another way to do it is to release a new AMI that has the bug fix. But more recently, we became more savvy. Our AMIs have code in them. So you release them, and they always check what's the latest version of the software in the AMI. And if it doesn't match our latest version, then it will upload the latest version from a server that we have set. So we don't even have to release a new AMI, which sometimes confuses students, so it auto-patches itself. OK, how do you evaluate? How do you monitor? What do you log? Well, we log everything. Everything the students do, we log and we monitor and we analyze. So on the Open Learning Initiative, OLI, after each project, there's a quiz module that they have to do on the project, and each student gets a unique set of questions. We log the bash, we keep the bash logs. We know all the AWS cost that each student has spent, and they submit their code on S3. So we use that for evaluation, we use that for cheat checking, and to monitor expenditure. And I'm going to talk about these in detail. So cheat checking, we think that cheating should be more work than learning. So the way we achieve that is because we monitor everything and we analyze all the work that students submit or do on the cloud, they have to do a lot of work to convince us that they did not cheat. So because of that, after a couple of attempts, then they recognize that I might as well do it myself. So there's, first we use Stanford's MOS to do code similarity check. Then we check their answers on the OLI quiz. Then we check what resources did they provision. How could they get the correct answers on the quiz but provision no resources on the cloud? Or time on task. Sometimes it's quite hard for you to log on a half hour before the deadline, get everything done. All of these become issues, and we become a lot better at identifying attempts of cheating. And we also do a lot of log analysis and correlation. How about budget? The first few years we offered this, we did not pay too much attention to budget because we were still learning. But now we've raised budget to become a first-class citizen. So now you don't get the full score only by getting the correct answer and meeting our performance requirements. You also have to do it within budget. So we release a per project module budget. We release a penalty chart. So we tell students, if you go above the budget, you get a 10% penalty. And if you go above 2 times the budget, you get a 100% penalty, which is a 0. So and we analyze all of this automatically, and we send them an email once they have broken one of the 2 thresholds. So the first week, there were 43 instances of drama. Oh, professor, you can't believe what happened, of 10% penalties and 600% penalties. And by week 8, that all went down to 0. Okay, we still see them every now and then, but now the most important thing I'm here to tell you is that students are a lot more thoughtful about budget. So now they not only budget their time, they also budget their expenditure on AWS. How much time and budget for development, how much for testing, and how much for drama when things go wrong and I have no control over it. And this is very important. And the last point is that, at a 10% penalty, you get double the number of resources. That's a decent trade-off if you're stuck. So we don't want to make that penalty too high to dissuade them from continuing and finishing the project. Cost, everyone asks about cost. A big thanks to AWS team here and everywhere. We thank you for the support that you've given us, because without you, we couldn't have done this work. We have, in the first spring, we spent $300 per student. So anything on top of the educational grant, we had to pay out of pocket. And this last semester, given the discounts that AWS has implemented last March, and given our budgets and penalties, we think we're going to be around $150 per student per semester. So that's important, but a request to AWS, please implement caps. That would make our lives easier. Okay, outcomes. We have similar to in-class retention rates. So we are at 80% retention. So this is wonderful. Of course, we have students from many different branch campuses, and they're sticking with the course, although it's quite demanding. And of those who do stick with it, almost all of them complete it successfully. And these are the numbers of growth that I showed earlier. So lessons learned. This is always a work in progress. Never think that you develop a course like this and you're done and now you can offer it for several years. I think it's actually more work than an in-class course. You have to continue to update it. You have to continue to collect and analyze data and reflect on it. You have to run surveys and see what are the students thinking. Always look for bugs. Always update the content, especially in a cloud computing class that's evolving so rapidly. The activities I spoke about and the feedback, these have to be very carefully designed for you to make it an effective learning experience for the students. At 4 a.m. in their dorm room, they want to get unstuck. So if they've just watched the video and they don't get it, and the activity exercises the misconception and gets them unstuck through the feedback, that's wonderful. So you have to carefully think about the wrong answers so that you exercise these paths. I have the world's best TAs. These are the hardest working TAs, the most talented TAs, and without them, I cannot offer this class. I'm deeply indebted to them, and they do so much work to make this successful. So you need to know that without such support, the students cannot successfully complete such a class. So you need that type of very quick Piazza help, as well as office hours, Google Hangouts, and Skype calls. Luckily, we have TAs at all of the branch campuses where we offer the course. We videotape everything and make it available to everyone. You have to learn how to auto-grade or you cannot scale. And you have to not only learn how to auto-grade, you have to learn how to deal with bugs in your auto-graders. So when something goes wrong, you can't say, oh yeah, 300 students, let's go through them manually and fix that bug. You will just chew up your TA time and won't be able to respond to other things. So you have to be prepared to do this. And just like any other systems, they have the potential to break. So implement contingencies, be ready for them. We haven't had to use any of our contingencies, but we're always ready if things were to break. What are we planning for the future? Well, we'll continue to offer the course and grow it based on interest from within Carnegie Mellon. And I get a lot of email from people outside the university asking for access, and I'm starting to think about how to offer it as a professional development course. We want to increase the scale. This is all about big data. Budgets are limiting, but we need to be more creative. And how do we make students work with terabytes of data for all projects and maybe provision hundreds of VMs? Develop new projects such as mitigating dependence on spot instances automatically, tolerating not only faults but transient faults, which are much harder. Mobility and the cloud, as well as streaming. Streaming is becoming very hot. We are exploring IAM roles, so now all of the students are linked to our account. So we are responsible for any mishap that they might encounter. We're thinking about IAM roles, but we want to do it so that we still have access to their expenditures and we can run our analytics for evaluation and cheat checking. Some students like to use their credit card to open a new account and do some testing that's outside our budget restriction. So in the future, what we want to do is to authenticate the AMI with the account that we have on our record so that they can't do any work unless they're doing it using the account where the budget counter is being measured. And then grade analytics, visualizations on grades, anomalies. When one student out of hundreds has a bad week, you need to be able to identify that and reach out to the students, and you need to do that automatically. So with that, I'll end, and then I'll be happy to answer some questions. But let me do this. Let me show you the scoreboard. Do we have time, Ken?
Yeah, absolutely.
Great. All right. Okay, so this is phase 3. These are the student submissions of phase 3. I'm going to reload and see if anyone has done any work. So here we have Team Star and Team A Cloud that are currently working. They have submitted 2 jobs. Let's look at the scoreboard. The scoreboard for phase 3. You can see that Team Cyan and Team FDU, their total score is about 85. It's due next week, so they're making good progress. This is good. This is their performance on Query 1. This is their performance on Query 2, Query 3, Query 4, Query 5. And they see this in real time, and they know how well they're doing compared to other teams. That encourages them to start early. That also makes them recognize that it's doable. It's not impossible, so that it motivates them to start. And then finally, I want to show you, so we've taken the open source tool from Netflix ICE, and we've instrumented to our course. And here you can see the students' use of AWS from the beginning of the semester. So every little bump is a day, and every hard and sharp bump is a deadline. You see, we're all still deadline-driven. Towards the end, you start to see them merge over each other because that's when the team project has started, and then we separate all of their usage by asking them to tag all of the instances that they use. And if they don't tag, there's also a penalty, and we have scripts that help us analyze that. Okay.
Great. Great. Have a seat.
Thank you.
So like I say, I'm going to ask a few questions of Maj, but I really want to open up for you. I think you can all see that he's just doing some amazing stuff within his class and the evolution of this class over time. So that's my first question. So you've been using AWS in education grants since, I believe, 2012, right? What do you see has changed the most since then in the way you approach the class to now?
Most importantly is that students are not working on infrastructure within the university. They're actually working on a real-world infrastructure that companies are also using. So that type of activity that they get is an experience, is unparalleled. That also requires us to understand the nuts and bolts of AWS. And so we've had to spend a lot of time iterating and exploring what can be done with the resources that are available.
Great. We saw the demand in the class just skyrocketing over the past few years.
Right.
Why is driving students to your class and just to classes about the cloud in general?
So I think they all know that the cloud, the data center is the new computer that they have to program. They used to learn how to program their own devices. Now they have to learn how to program the cloud. And they get it through interview questions when they're interviewing for internships. They get it when they meet alumni and they see what the alumni are asking them to develop their skill sets in. And I think they recognize that it's going to give them a major career boost, and that's why they have grown. The other thing is it's given them a competitive advantage at interview questions also, which get to be harder, and the more insight they have, the better.
Yeah, so tying into that, what do you see as, when you're looking to graduate your students into the workforce, what do you see some of the key skills that they get for cloud-based employers?
Well, they need to understand first how the cloud works, what can be done on the cloud. Budget issues are extremely important, performance, transients, and all of these things. How do you respond to, this is a shared resource. How do you deal with interference, and how do you deal with variability? And then you guys upgrade you evolve rather quickly, so they need to be able to deal with that as well. The other thing is, when they have a bug on the cloud, it's very hard to debug. So they have to learn how to collect logs and then analyze them carefully so that they can identify where the issue is and address it.
So your course is run, I believe, again, in 4 continents across the globe. Are there ways that students approach your course differently across the various geographies?
So these are Carnegie Mellon students, so they've been admitted through the same admissions process, and we believe they have the skills they need to be able to take the course. So we don't see any difference in their skill sets. What's good, though, is that since you are available globally, and they write programs to address that, so they understand latency and the nuances of that extremely well. Availability zones, what does it mean to remain within an availability zone and have redundancy across them?
Do your students deploy in multiple regions?
We don't right now. We keep it within availability zone because we need to control the range of performance that's acceptable to get the grade. So once we start to spread them across, we cannot measure that variation very well, so we cannot assign a grade automatically.
Oh, that's interesting.
Yeah.
So we're driven, obviously, at AWS to make things as powerful and as seamless for students as humanly possible. What is it that you see that we're doing well, and actually then to be self-critical, what should we be improving upon?
Most importantly, your services are very mature and very easy to use. I think that's a major issue for us as well as for the students. The other thing for faculty is that the quick response to a grant request, and I encourage you all to submit a grant request. Not only for education, there are also grants for research. So you can get grants from AWS to do your research, which is great. So sometimes I get a response in the same day. So for busy faculty that are thinking about using the cloud, just making that quick jump into it and having access to it so that from the morning to the next day you can start doing work is, I think, wonderful. With respect to things that can improve, capping is a big issue. You develop your services for companies that want to adopt the cloud, not for educators. I think if you take us into account when you're thinking about these things, that will be helpful.
So to key in on the budgeting issue, and we will continue to improve and iterate where we are on that issue around capping. Your budget mechanism, though, is fantastic. I know when we saw it, we were dramatically impressed with the way you use that in the grade structure. Are there things that we should be doing, whether it's sharing scripts or other things, to help that design for the classroom?
From what I've seen students learn, I think if you can enable faculty to dial up a budget for a project module and say, you're on full or you're close to empty, and now you're running on fumes until you can't do anything anymore, will be valuable for us. And if we can easily do that, that'll be marvelous.
Yeah, I think that's something that, again, in the coming months, we want to iterate on the right thing for that arena.
Right.
What are some of the biggest challenges you face when adopting AWS for your projects and for the students?
I think we covered some of it. This is a shared resource, so we don't have full control over who is there and what they're doing, and if they're going through a peak load right now and how that's going to impact our performance and auto graders. You also evolve quickly and improve performance, and you don't notify us, obviously, and say, oh, we're going to release something new next week. So we have to then do an arms race and go and figure out what are the right ranges for our auto graders and things like that to be able to respond quickly to whenever you release an upgrade to the instances. And the variation in performance continues to be a struggle for us. But I think we're getting a handle on it, and we have to become experts. I don't mean as good as some of the experts I've listened to here, but we have to know a lot about what's going on so that we can instrument the project in an effective manner.
So not to dig in too deep and to force you to reiterate some of the new services that we launched this week, but have you seen some of the services that were announced that you could say, well, we should be bringing this into the class?
Absolutely. I think many of the tools, primarily Aurora, I think we're going to include it in our storage module for sure.
Fantastic.
Yeah.
So you obviously have been a fantastic experience teaching the class over time. You're teaching to certainly some of the top students and top future employees at Carnegie Mellon. what advice do you have to somebody who's just starting out approaching AWS in the cloud for their classroom? How should they be thinking about structuring the course?
I would say pick the easiest project that you understand very well, and think about only if you migrated it as is to the cloud and you didn't have to do anything new. And then test and iterate. What we have learned is that after we get something basic working, then we recognize that some of the services actually influence what we can do in a project. And in certain sense, like the closed VMs and the students control the load generator, it enabled us to actually become a lot more creative as to how we can test the students in a way where the learning is better and the work on our side with respect to monitoring and grading is reduced a little bit.
Yeah, fantastic.
Yeah. So as everyone says, start early, fail often, and iterate. I think the more you do it, the better you become at it, and the better the learning experience will be for the students.
It's like a startup in the classroom, isn't it?
Yes, absolutely.
So, Maji, the stuff that you share is so fantastic. I'd say the other thing that's important for people to know as they're building classes is we have a wonderful community of educators who've already been there, who've received grants. We've got to do a better job at making sure that that community is exposed to all of you, and we're going to be working on that as well. But the resources that we have from people who've already done it is absolutely great. All right, now I'd love to take some time and ask questions that you have of Maj. Yes, sir.
Yeah, that's a very good question. We get students primarily from the School of Computer Science and the College of Engineering. But we also get students from our Heinz College dealing with policy and technology. We also have students from entertainment technology as well. So we have students from the entire gamut, and often we have researchers that contact and say, I want to take this course, and we actually force them to register for the course so that they can get access to all the technology. And I had a student last year from the Tepper School of Business that needed to analyze large data sets for her dissertation. And she signed up for the course, had a lot of time invested to catch up with all the different tools that she had to learn, and then she went on and completed her dissertation. So we are noticing, and at different campuses there are different programs. So there's a nice diversity, and the way we deal with that is we don't ramp up the course heavily in the beginning. Our slope is quite low in the first 4 weeks, and then in week 6 it really goes up. So that gives them a chance to learn the tools on their own and invest the time that they need to, whether to refresh what they knew before or learn new tools. Computational biology, of course, they're part of the School of Computer Science. Yeah.
Great.
Yeah.
Any other questions? All right, fantastic. Well, we're about at time as it stretching.
We have 15 seconds.
15 seconds. Chance for the last one. All right. Well, again, Maj, thank you so much.
My pleasure.
We appreciate you all for coming to this. We hope again that you had a fantastic reInvent. Enjoy the rest of your time in Vegas, and come and see us again next year.
All right. Thank you.